I'm going to talk about asynchronous programming in RxSwift. Why asynchronous and not reactive? We heard that reactive is cool, and it's a way to do asynchronous programming, but usually we don't think a lot about why switch to reactive and try reactive. We tend to think, well, reactive is cool, everybody's using it, but we don't analyze why asynchronous programming can be hard. So I'm gonna show you what is Rx, and I'm gonna try to explain you how R can be asynchronous programming, and why RxSwift can be a solution to solve a lot of problems. First of all, RxSwift, it's a port one-to-one of .NET Reactive extensions. It's one of the most beautiful things Microsoft gave to the community. If we compare and we think about Windows Millennium or SharePoint, that actually were kind of strange, but Microsoft delivers very high quality stuff, and reactive extension in .NET were one of them. And but we have to understand that learning a ReactiveX is kind of learning a language. Marin said it a couple of days ago, and I think it's quite a good thing. When we learn ReactiveX, RxSwift, we have three phases. We have the first one where we learn the basic, and then it's like learning a new language. So if you are learning Portuguese, the first thing that you learn is posso ver pouco de água, or cadê o banheiro? But you just repeat it, you don't really know how it works. Then the second part is we learn semantics, rules, how the language works. And then you start building more complex phrases. At the end, you master the language, and then you are finally ready to have a long conversation with a Portuguese, or in my case, a Brazilian guy. And so let's try to understand that second part in Rx. ReactiveX is a combination of best ideas from the observer pattern, the iterator pattern, and the functional programming. This is the definition ReactiveX.io, the official website of Rx, basically. You find a lot of nice documentation. And let's try to decompose the three things that are in violet shades. First, iterator pattern. The iterator pattern is probably the most simple one. I don't think there is any simpler, but you basically have something, an entity, that gives you back whatever. You can have pizzas, for example. As you might understand, I love pizza. And we have, I don't know, I have a pizzaiolo, and this pizzaiolo gives me pizzas. So I ask for pizzas, and I get back pizzas. There is next, I want more pizzas, and I get back more pizzas. What is this? It's pulling, because when a pizza is ready, I just get it. I just try to get pizzas out of it. This is with, it's called generator. So we have this nice generator type that has this nice next function. And this next function says, well, if there is something, I give you something, because it's an optional. If there is not, I give you a meal. So it's up to you to do the logic. And then we have the observer pattern. Apparently, the observer pattern is not so understood as I thought in the first instance, but the observer pattern is basically something that we observe. So I observe my pizzaiolo, and every time the pizzaiolo has a pizza ready, he raises his hand. So I say, hey, a pizza ready for you. And then I get the pizza. I get the notification, and I pull the pizza out of my pizzaiolo. And I'm really happy with it. I'm storing a lot of pizzas, and I'm really happy. I like it. And this is actually a producer and consumer relation. There is some entity, a pizzaiolo, that produces the pizza, and I consume them very happily. But there is a notification. There is this notification. He has to raise his hand. And translating this in code, an example is NS Notification Center. And NS Notification Center is very useful. We send a notification, and all our objects that are subscribed to that notification is going to be notified. And this is actually what happens. It's simple. Again, next pizza, 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 whatever. As much as I get, pizzas, I get a lot of pizzas, I get fatter, 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 so I have to stop sometime. But yeah, I like pizzas. But what happens if my pizzaiolo starts to work in a different thread? So he works in another thread, and I work in a different one. And this is actually start to be quite difficult, because at some point, we are going to need to lock that pizzaiolo. Because once the pizzaiolo raises hand, I'm going to try to pull that pizza, but if I'm not fast enough to consume it, it's going to produce 3, 4 different ones. And then when I try to pull back another one, I maybe miss 2 or 3 pizzas. And this is actually the basic and the original observer pattern, because we notifies the objects that are subscribed. If you see notify doesn't have any variable or anything, it's not passing any objects through the notification. But NLS notification pattern added this nice sugar user info. But it's still a kind of pull interaction. And this is a big problem, because when you pull, then you have to start lock the pizza in some way and wait for, I don't know, whatever happens. And when we start to add locks, then we are adding unpredictability, because we cannot predict anymore the behavior. We don't know when it's going to be ready. We don't know whatever is happening. We don't know in what status we are. And it gets hard to predict the behavior of a software. And even more, we don't know if we're going to miss or not any notification at this point. So the result is you are using a very nice project. You have a very nice project with observer pattern, iterator. You are combining all of this. And suddenly somebody at the management figures out in the morning before you are ready to ship that there is a problem. So you receive an email like, I noticed we're having random deadlocks and race condition in whatever. We need to fix SASA. I'm considering logs. Actually, I think we should use logs. Please do it. It should be ready by tomorrow. Management said we have to ship, so there is absolutely no way it can be longer than tomorrow. Even if I'm pretty sure you can do it by tonight, you know, you are a very smart guy. Remember, sleeping, it's overrated. So this is actually your reaction to that email. But it's not that. So a few hours later, actually this is, you notice, it's just after lunch, because in the morning before the ship, usually somebody figures out, oh, we have to test it, the app. So yeah, a few hours later, coffee break, the boss goes to the coffee break and talks with another engineer, and this is actually what happens. Yeah, that guy pointed out that we can use a serial dispatch queues. Do you think it's possible? No one loves logs. No one, even if before I thought, let's use logs, but yeah, logs, wow. So if we can avoid them, would be great. But if you are already done with logs, and I'm quite sure you already finished the logging thing, can you maybe do a second version with queues, and run a performance test, and pick the best one? Let me know. And probably I'm missing something like, and tomorrow I'm gonna leave for the holidays, so it's better that you finish today. And this is actually your reaction. But why asynchronous is so much pain? Dealing with multiple processes requires some point synchronization. If my pizzaiolo is too fast, producing so much fast pizzas, I cannot keep eating and storing them. So at some point, I need to synchronize myself with him. I have to wait him, or other way around, is producing too slow pizza, so he has to speed up a little bit, spreading the work in different threads, or whatever. Logs are a very valid solution. They are, because they are being meant and created to be used across different threads, but they are very difficult. If you have a solo project, it's going to take time, but you can manage to do it. But if I have a multi-team project, I can assure you that when you introduce the first lock, it's going to be painful. Because then somebody else is going to introduce a lock in another part of the project, maybe you are not aware of, and then you start having new problem with synchronizations because the locks are not synchronized themselves. So pooling might be kind of a difficult way to be implemented in the correct way. So solutions, let's try to, instead of pull, push. Let's try to push. It's a kind of, looks like a good idea, isn't it? Basically, instead of pulling, let's push. And the changes here from the previous graph, it's basically that I don't actually ask anymore for pizzas, they are throwing to me. And this is even worse because, I mean, I really love pizzas, so I'm not gonna stop. And I subscribe to my pizzaiolo and they say, well, I really want pizzas. And then the pizzaiolo, every single time my pizzaiolo has a pizza ready, the pizza comes to me and I store it because I'm actually the database and I'm storing my pizza safely. And when I store it, all the pizzas and I feel full, okay, I don't need anymore. The advantage of this approach is basically that the consumer and the producer, they can work in different threads. And in between, we do some kind of locks, of course, because they are underneath, but this is actually something you are not going to care if you use Rx. And another one big thing is that we can have errors and termination. If the pizzeria gets on fire and something happens, there is no any more pizza, so that's an error. My pizzeria is not anymore there, unfortunately. Or I had a lot of pizzas and the pizzaiolo has any more ingredients, that's a natural termination, no any more ingredients, so there is no more stream. The consumer is so high, I can consume my pizzas in a different thread. And the combination of the generator and the observer together from pull to push creates the entity of an observable in RxSwift. The new entity is basically able to produce value pushed to the observer that are subscribed. And what you get in return is a subscription, and you can manage that subscription. At some point, you can decide that you don't need it more. An example, you have a UAVI controller, you declare your nice piece of code with Rx, you subscribe to an observable, and then when you release that UAVI controller, you delete the subscription automatically in the dialog, disposing it. So you are basically able to control all the flow and the life of observable observers and subscriptions. And this is good because you can predict it. You cannot predict for sure when it's going to be computed, because that's not under our control. But you can predict the result. So this is actually great. And this kind of approach requires a kind of entity. And this entity, this basic big entity, is an event. In this case, in my example, the event is a pizza. So I send a sequence of pizzas that can actually contain 3 different types. It can be actually the pizza itself. It can be a termination, so there are any more pizzas coming from a pizzaiolo. But on the other hand, it can also handle an error. So we had an error in the flow, something from the pizzaiolo went wrong, and there are already more pizzas. And we can try to recover it, we can close the stream, we can do whatever we want or we need. And this is actually how the event thing is coded in Swift. We have an enum with case next with element, an error that can be of any error type, and a case that is completed, so we terminate the stream. But where is the relation with what I showed you before where is how I can relate it to the generator. This is actually a nice table that shows you in generator that usually single thread. We pull data, so what we have is a next to T. In this case, we have another pizza. Or we can have an error. In Swift, there is no, it's not try next, but you can model in the way that you throws out of your collection. In .NET, actually, the iterative pattern has a try. So you actually you have to handle exception if the iterative pattern throws an exception. Or in generator, in Swift, if it's nil, it means that it's completed, there's nothing more left. On the observable word, that is push, we have on next, that actually is wrapping around my pizza, we have an error with the necessary error and incomplete. And the end actually of this can be reduced to reactive observable model allows you to create a stream of asynchronous events with some sort of simple composable operation that you use for collections of data items like arrays. So with this simple event, this small enum that we store the information with a push interaction, we can then start to compose them, and this means functional programming. That was the word missing from the first thing I showed you about reactive aids. And functional programming in RxSwift means we can approach an observable like a collection in the same exact way, because a collection is there usually single thread, you can access it, but technically it's not different from a stream of data that comes time by time. And this manipulation can be really easy with functions that we already know, like map, filter, flag map, merge. They are all there from functional programming since ages, and we can use them in a synchronous way. And this makes the usage of observables very simple. And the operators that we can use are different. We have transforming operators like delay, map, scan. We have combination operator, merge, sample, combine lattice, concatenation, filtering operation, distinct element out filter, math as well. We can reduce, mean, max. But the cool thing, I think, of Rx is the representation. We can represent and write and paint all streams in a very simple way. We can define, this is actually from Eric's Marbles very website. I'm gonna share after all these nice things, where I get all these nice things. And the example is delay. It's simple representable with one observable that sends out event. I process the delay, and then I have a delay of n seconds. Easy. Merge, I have two of them, two observable, two streams of data. And the merged one is basically sending all the events that they reside from the two in a single one observable. Or sampling. Sampling sometimes looks quite useless, but think about, I don't know, a timer for a running app where you want to keep track of laps. So the first stream is basically the seconds that you are running, and ABC is the user pressing the button and getting back at what time is your lap. So at what point are you actually running? And you press the button, and what you get back is actually the last event. So you get back your time, and you display it. We have the bounce that avoids to overcharge the consumer because maybe the consumer is slow. So with the bounce and we avoid to have it dying or starving by resources because we are pushing too many events into it. Or reduce, that is usually using maths. So we can process like calculations, sums. If we have a string, we can merge it, whatever. But I show you a lot of good examples, and most of the things are not new. We use a concept from games of four patterns like iterator, observer pattern, and functional programming, pure functions. But where is concurrency in Rx? The main concurrency part is handled by the scheduler. I'm not going to talk a lot about schedulers, you just have to know that they are there. And the scheduler is actually where the tasks are processed. So we can process the consumer in one scheduler and the producer in another one. 99% of the time you're not going to need to write any scheduler because the one provided by the RxSwift 99.9% of the time are enough. So you don't have to care too much. You can just play with subscribe on and serve on and then change them and try them. But there is absolutely no necessity you have to write your own scheduler unless you have really strange problems. But that's actually very uncommon. So I'm going to show you a small demo that is going to be very quick. Yep. Okay. Well, that's where that kind of actually say yes. No. Yeah. Okay. Okay. Basically, I have a very simple Node.js chat example. It's the same one it's on the Node.js website. Who has done work with Node.js here? Okay, not much. I was expecting a little bit more, but okay. So I'm using that code. In my example, I wrote that chat and I used SwiftAveiro in Swift. And what I came up with is that this code actually cannot fit this screen. Okay, no, it's full screen. That's not going to happen with the success. 84. Yeah, I know that. I know. But it's actually common 1, 2, 3. But it's way faster. But I don't know why it's still building. Okay, so just to explain a little bit of the code, this is actually what you have in RxSwift. What happens is that we register to socket.io events. An example is user. This is actually not it's not socket.io code. So it's related to the UI. And the user is nothing more than a behavioral subject that is a read and write entity in Rx, and with an empty value as default value. So when the user opens the app, and it should be there like in a few seconds, I ask for the username, and then I get back the response from the server that I'm in the chat. Okay, let's see. We are very close. Yeah, come on. Yes. Okay. So this is actually what we have. It's a simple chat. Then I pick a username like team. I'm just the only user online at the moment. And what we have here is that Socket.io is throwing events, so it's really easy to be modeled. And I send all the events through an observable, and that is called the Rx event. And then what I can do is filter them according to the name. So the first line is say, well, if event is connect, I go on. So I filter all my data that is coming from this Rx event observable. I map the result returning nothing, because if I connect, I just need to know that I'm connect. There is no data. So I'm going to display that Rx chat is connected. And this is actually what happens here. The second one is my login information. So I log in, and the server replies back with the login information. How many users are in the chat. So what I do, I check that event, it's login. I make sure that actually it's giving me back the data, the correct data. In the case I have no items, it's absolutely not necessary to go on, because there is no information. And I get back that array, and because of course JSON is modeled in different ways depending on the language. And then I subscribe to this observable, and what I get back is a login information. I print the number of users that are currently in my chat. I use JSQ message queue controller in this example, that is very well done. These examples can actually be improved, but this is not important here. And the Rx event that is next is new message. I receive a new message from somebody. So what I do is I get a new message, and of course because it's JSON I have to check that actually the message is in there. I map again, getting back the message information, and what I do is this is actually my message. So I get the username, the message. I still have to check, because Swift is very type safe, so I have to make sure that I actually have data on it all the time, and I display the message. That's it. Last one, actually the last two ones are when a user joins and when a user leaves. So same thing. User joined, user left, it's basically the same code with a different message. So I give back I receive back from the server the information how many users are still in there and who left the current chat. And this is actually what you have. And on the other side, I can have a simple chat on the web. So I have team saying hello to Adele, and then Adele reply, yeah. What's going on? Yes, that's correct. No, I'm saying that it's not working. Why it's not working? Okay, so apparently there is something that in the chat. What? Yeah, okay, that's strange. Didn't notice. So let's see if I rerun the app, what happens. Yeah, live coding. So yeah, 2 users online. So I have team basically saying hello. And now we have an hello, and Alda says it's me, of course, because basically it's sound, so there's nothing new there. But the interesting point here is that we have, sorry, let's get this removed here, because it's very annoying. We have RxSwift here, and on the other side we have JavaScript. And this is actually what it's the code in Rx JavaScript, in Rx.js. I don't know if you can actually read it correctly. It's better right now. Is it readable? Yeah, basically we have the same code, Rx JavaScript, Rx.js. We have, let's get a new message, for example. I filter the data, I get back the data, and I check that the event from socket.io is the new message. Exactly the same thing I do here. Filter. Then I map the function, I get back the data. Same thing here. And I subscribe. This is actually basically the same thing that is here. Of course, it's processing HTML. But the logic is pretty much the same. There is no big difference between RxSwift, the concept of RxSwift, and the concept of Rx.js. And this is actually something very interesting about Rx in general. So let's get back to my presentation. No. That's not normal. Okay. Conclusion. As we said before, what I actually did right now, it's moving from the imperative world to the declarative space. And this means that we are declaring the behavior of a software or an application during the initialization. We have a huge block where we say my app is gonna act in this way, depending on the event that comes from whatever observable it is. I don't have to care anymore to have logs and synchronization strategies on my asynchronous code. That is quite the most difficult part, synchronize when you are async. And the other thing that this approach limits a lot the bugs that you have in the code because you are doing a locking in a wrong way. And unfortunately it can happen not because it's your fault, but because asynchronous programming is hard. It's not something that we are used to, but we have to because in the last 10 years we say the increase of the core. So we have to use all this power in some way. It's there, why not use it? We need to do asynchronous programming all the time. The last quick part is the most controversial one, but I have to do it. Demystify Rx. There are some cool stuff going around about Rx, especially in the Slack channel and on other articles that I read on. Rx is thread agnostic. There is no asynchronous programming going on where you subscribe, where you unsubscribe. It's all under your control. It's very basic. I can even say that it's stupid because it doesn't do nothing on the asynchronous way. So subscription, unsubscription, everything is thread agnostic. There is no threading going on. And another thing is that events are single threaded. So when you push an event, you are not pushing that event in any other thread than the one that you are currently using, unless you are using a different scheduler. So there is no multi-threading going on here as well. It's not something magic. You have to explicitly say it if you want your scheduler, your observable to be processed in a different thread, or if you want your consumer to produce the event in a different thread. It's basically everything is under your control. There is no magic. There is no automatically in another thread thing. Everything is explicit. And it's really important to understand that schedulers are not related to threads. So if you have a scheduler, it doesn't mean you have a thread. You can have 10 schedulers running in the same thread. It's possible. It's totally possible. So schedulers, the ones that we provide are enough. Just use them. If you have border case, file an issue, we discussed, maybe there is an error. But the ones that are there have been proven with tests and used since a year or so are enough. And the last one is quite controversial, but Rx is not functional reactive programming. And this is something we state in the ReactiveIs IO website. Functional reactive programming is a concept that comes from Conall Elliott, end of the 90s, and it's really functional. as I showed you before, Rx is not totally functional. Only few parts of Rx are functional. Map, filter, pure function. But under the hood, it's basically classic imperative programming with observer pattern and an iterator pattern. So it's not FRP. What's the downside of Rx? Rx takes time to be mastered. As the first quote of Mari, it's like a language. You have, unfortunately, you have to get your time and learning. It's not an easy walk. It requires a reset of the way you think the software. Because once you get into Rx for the first time, you're going to probably use it to cache your images, to do your storage strategy, to display stuff on the UI, to process long tasks in the background. And you're going to use Rx everywhere. If you step into Rx once, you're going to use it everywhere. It's going to be everywhere in your app. And in the first time, debugging might be quite hard because we are used to use the stack trace and we read all this assembly code and we do PO and we check data. In Rx, we have to print the events out. And we do the nice marbles that I showed before. And we try to figure it out what's going on. But the boogie, it's radically different. But once you get it, it's actually be nicer. But the pros are, I think they are higher. First of all, it's polyglot. You can have RxJS, you have Rx.NET, you have RxJava, you have RxPHP. So that is new. I wasn't aware of it, but PHP has Rx, it looks like. So this is actually, it's you can talk with Rx Android. This is actually something really great for Android programmers. You can talk the same language with people using different programming languages, and you know the concept is shared across all the platforms. Declarative programming can eliminate a lot of bugs in your logic and the way you write asynchronous code. With Rx, the underlying nature of your observable can be radically changed. So you can change the computation, the way you compute a certain task, without breaking the contract with the consumer. And I think this is really something important. I mean, the same code, side by bottom up in this case, it's basically the same thing. I think it's great to read and write the same thing with two different platforms. Rx has momentum, and it's having a lot of good people stepping into the project. We are growing day by day in a Slack channel. And don't spend time writing synchronization strategy for your asynchronous code. Invest it in writing the logic. Don't just turn like Edward Norton in Fight Club a zombie because your boss asked you for an NS lock, and then you have to stay up night writing a synchronization code, and then you don't have a life anymore, and yeah, you end up with, I ended up with him. Sources, reactive XIO, intro to Rx.com, very beautiful. Marbles are from Rx Marbles. RxSwift.org for sure, that points to our repo, and you can have a lot of information. And during actually the last time I had this talk, somebody asked me, well, it's very hard to understand reactive programming in the first instance, so we actually need an in-between step. I suggest to you to check futures. Check futures, because the analogy is very easy. Future, observable, read-only, you can only read. Promises are subjects, read and write. And basically, futures are the gateway drag to rack and rack and RxSwift. This is a beautiful trick. Thanks for listening, and if you have any question, I might be happy to answer them.
Questions? No? No?
So I just have like this doubt in my mind about the push versus pull, because with push you are basically modeling a signal, you know, something that
exactly.
will happen. But for example, in the example you gave, how do you guarantee that you will not receive a message before you log in? So for example, if you receive that message signal before the login is complete, how do you deal with that?
Well, this is actually how, for example, Cocoa works. You have a lot of status boolean around object-oriented implementation. So the way you bridge the imperative word to the declarative word is using subjects in this case. So you get an information from a good example, I think, is reachability. So if you have connection or you don't have connection, it doesn't make any point to receive or listen for events from the socket.io. So what you can do is that you have an observable that checks that you have connection, and then you have another observable actually sending out the messages to the socket.io implementation. And then you can basically say, well, if I don't have connection, just return an error, and I retry when the observable of the reachability fires an event saying, hey, I have connection. This is actually, there is, Marin actually is working on an example in some app, but if you want, we can discuss it later in the front of the code. That is way easier.
Yeah, just one last question. Would you model like an HTTP request using signals? Or would you prefer like my question is, would you model it with push or with pull?
It's actually using observables, it's push. So I will reverse the arrows. So I'm not gonna wait and pull when somebody says it's ready. I'm gonna just let the NS URL session entity push it when it's there. Because if you notify, sometimes you are not sure your notification has been received. The NS notification center, there is no guarantee the notification has been received in the correct thread and you are processing it correctly, because you don't have information. If you push the event is there, it gets pushed, you process, you might have an error, it happens, but you know it's an error, or it's terminated, there is no any more data, but you have an information.
Thank you.
You're welcome.
Okay, I was wondering, imagine, for example, that some developer is already using reactive code, for example. What could you tell her or him? Why should they use Rx?
Why?
Yes.
First of all, I'm going to say that if you are happy to use reactive Cocoa, keep reactive Cocoa. There's absolutely no reason you have to switch. It's a completely different world. I'm not going to tell you why, because this is actually, it's going to end in another talk. Because I can talk like 40 years about the difference between reactive Cocoa and RxSwift. Yeah, I think RxSwift is great, and I suggest to use it if you have a platform team. So you write web, Android, and iOS, basically modeling the same streams, same events. And you can talk only about the logic. You don't have the underlying implementation to care about, because the strategy is there. It works in a similar way, predictable way, all across the free platforms. And yeah, but if you're already used to rack, the step into RxSwift might be very painful. More painful if you don't know reactive programming in general, because it's a completely different world. They are separate in two different areas of reactive programming.
Great, thanks.
You're welcome.
Anyone? Sure. No?
I just came up with another question.
Sure.
Which one of the URLs that you said they were good to start with Rx will contain the very first words, like bom dia, like the obrigado and so on? So if somebody doesn't know anything about reactive, which is the
If somebody doesn't know anything about reactive, I first consider intro to Rx.com. It gives you, it's .NET code, but the information there is very useful. And on the same time, check reactivex.io. There are two great resources to start learning Rx. Intro to Rx gives you just the necessary information to understand observables, observers, schedulers a little bit. There is a section that goes very deep into schedulers, but it's not necessary that you read it in the first instance. And then you go to reactivex.io. It's basically the same for other platforms. If you learn it once, you can carry your knowledge to other platforms.
Hello there.
Hello.
In the slide about the cons of reactive, I could sum them all up into maybe learning curve. Time to master, how to debug, different mental model. But let's assume I've went through the learning curve. I know OOP, I know ReactiveX. What would be the cons of ReactiveX? So maybe, I don't know, I'm looking for places where wouldn't applicable be applicable or something like that.
Actually, can you repeat, because it was very low and...
Sorry. So let's say I went past the learning curve.
Okay.
So I'm comfortable with the model,
Yeah,
but I'm also comfortable
with...
with OOP. So
Okay.
what would be a con of our ReactiveX? So
If you are comfortable with object-oriented and then you move to the reactive world, that's actually what you mean.
no, well, let me repeat. These cons for me, they all talk about learning curve.
Yeah.
So let's assume I'm past the learning curve.
Okay, you pass the learning curve.
So
then
what
there
would be
are-
then a con
okay.
of reactive or places where it would be suitable?
Cons of, well, once you mastered Rx, the cons are that most of the time you are dealing with bridging the imperative world. This is actually annoying sometimes. And the problem is that Apple did a very good job avoiding most of the side effects and problems in Cocoa. So if you model, like Rx Cocoa works amazingly. I mean, bind and all the information, all the helpers that are in the Rx Cocoa, they works very good. The problem is that sometimes, for example, in my example, I had one trouble. I passed the learning curve, and then there is basically every time that you compute an observable, this observable will be recreated because it has its own computing thing, and then you dispose it. But in my example, Socket.io basically has a single handle for the callback. And if you do this multiple times, it gets rewritten, and then only the last observable works. So I had to go check the original code because I was expecting that all the callbacks are added in the order I add them, which it was not true because there was no place in documentation stating. So I had to write shall replay. So that basically says, get that observable, freeze it there, do not duplicate every time I have a sequence, and then from there you create the other ones that I actually need to filter events and get the data and blah blah. This is actually the the cons of Rx once you are in the wide world of libraries, open source libraries. You're welcome.
Okay, since we're a bit scrambling for time, can you talk on the outside? Sorry, because we talk a little more than we wanted at lunch. Okay, so Junior, thank you.